will now look at running the applications with the different systems with only one thread. And doing that, we'll reveal the overhead inherent for one thread, obviously. Okay, so one could expect that there should be no significant speed up, meaning faster program compared to the sequential C++ program. But when this is below 1, the program is faster. And as we saw for the OpenMP version, sometimes, I mean, we didn't see it, but the IBM researchers investigated it and presented it, that the register allocation was better for these codes. But that is not an inherent something that always applies to OpenMP programs. Obviously, it's just it happened to be that. Okay, so for some of this, we will not spend time on exact what happens for all the situations. But what we can see is that as two observations, the software transactional memory often makes the program much slower, but it's not intended to be run only with one thread, obviously. But it's interesting to see what happens if we only run one thread. Okay, and then also that the short transactions also can slow down. So what this show is what we can have in mind as for expectations when we run multiple threads. Clearly, we need quite a number of threads in order to get performance improvements compared to the sequential code, since the single thread versions are typically slowed down. Okay, so here are speedups for different number of threads. And now we want, I mean, these graphs should be as high as possible. Higher is better. So here we have the number of threads that were measured, and we will not go through all this, but we can make some remarks that the long transactions often are good, but there is none which is consistently better all the time. So the transactional memory, I mean software transactional memory, it's not that bad. It's sometimes quite useful. Okay, so how can this be improved for the next generation of machines with hardware transactional memory? We will move on and go to first Power 8 and then to more evaluations, including with Intel.